Okay, quadratic word problems. Superman throws a boulder, and it's an overhand throw, and it's going to follow an arc given by negative 0.02, x plus 4, x minus 24, where y is the height in meters above the ground, and x is the horizontal distance in meters from Superman. A couple of things here. Let's just have some fun. What form is this in? Is this standard form, vertex form, or factored form? Factored. Excellent. This is factored form. Let me ask you a question. This 0.02, is that going to be a stretch or a compression from the original base curve? Compression. The negative, does it open up or down? Down. What are the zeros? Where does it cross the x-axis? At what x values? Negative 4 and positive 24. Very good. Excellent. Draw a diagram representing this scenario. Okay, so there is Superman, and he is throwing a rock, and it's following an arc, and I'm assuming it's going to hit the ground. So Superman stands here, and there's the ground over there, and this is a rock flying through the air. You know that a boulder is another name for a rock, right? Yeah, boulder's definitely bigger. Big rock. There we go. So now, mark the x and y axis on your diagram. So I'm thinking my y-axis can be here, and I'm thinking my horizontal axis can be here. Do you agree? Given that this is the height above the ground, so I'm throwing it in the air, it's an overhand throw, and then it goes through the air, and then it's going to hit the ground. Notice the parabola continues down this way. And notice the parabola continues down this way. That's the parabola. That's not the rock. Calculated the y-intercept of the parabola and mark it on your diagram. Well, that's going to be wherever I threw the rock from. And looking at this, calculate the y-intercept. Probably the easiest, like you have a number of ways to do this to get the y-intercept. I think that's what you have to realize, is that you have choices now. You could expand this into standard form and read the c value. But what a waste of time. That would take a lot of work. Much easier, simply, if I'm going to find the y-intercept, set x equal to 0. So if I set x equals to 0, this will be 0. So it's going to be negative 0.02, 4, negative 24, using my calculator, 0.02 times 4 equals times 24 equals, it's 1.92. It's a negative times a positive times a negative, so it's going to be positive. So the y-intercept is going to be 0, 1.92, which means Superman throwing the rock with his hands up over his head is going to be 1.92 meters tall. Determine the x-intercepts. Well, again, we have the same equation. I could go through all of the work and set y equal to 0, which will give me 0 equals negative 0.02, x plus 4 and x minus 24. And thinking about what values will make the right-hand side equal to 0, it's going to be x equals negative 4 and 24. And I'm supposed to mark them on my diagram. So one of them is way over here. That's the 24, 0. And the other one is behind Superman, -4, 0. And again, that's where it is. That's the mathematics of the situation. But certainly the rock was never there. That's just the parabola finishing off where it would be on the graph. The part that is real as Superman is, that's the part that's real. Calculate the vertex of the parabola and mark it on your diagram. I'm going to bring this into focus. Sorry about that if it was out of focus. I'm going to make a little bit, the vertex is going to be right here. Okay? So I'm going to go looking for that vertex. Well, that vertex is on an axis of symmetry. Had this discussion with the in-class group today. So we've got an axis of symmetry running straight down there. So to find that axis of symmetry, you're going to take the zeros. I'm going to take 4, or -4, sorry, and I'm going to add it to 24, and I'm going to divide by 2, which is going to be 10, which means that this value here is x equals 10. My vertex lies on that, so I'm going to sub x equals 10 to determine y value. So y is going to equal -0.02, 10 plus 4, 10 minus 24, -0.02, 14, -14. Using a calculator, I'm going to get 14 times 14 equals, times 0.02 equals 392. Notice I didn't worry about the negatives. I do that at the end. Negative times positive is a negative, times negative is going to be a positive, so that's positive 3.92, which means the highest that my boulder gets is 10.3.92, is going to be 3.92 meters above the ground. Okay. So, what is the maximum height reached by the boulder? Well, 3.92 meters above the ground. Approximately how tall is Superman? Now, this is actually a bit of a misnomer because if it's an overhand throw, I'm assuming that his arms are upstretched, right? I'm assuming that his arms are up here when he throws it, and his boulder, when his arms are up there, for the kids at home, this is what I looked like. I'm assuming he's something like that when he throws it. We know that this distance is 1.92 meters. I'm not terribly sure that's what we would call the height of Superman. It's probably a little bit too tall. But for this question, that's what we'll take it as, and certainly when they say approximately. How far away from Superman will the boulder land? Well, this is Superman. Boulder goes thunk right over here, which is 24 meters away. All right, so that's the first one. So I'll stop there and let you do the second one, and we'll be back in a minute.